the way, so I'm going to hand the mic over to Max.
Okay, I have sharing my screen. Can you guys see it?
Yes.
Okay, so I have to say, Eric, hats off to the team. Absolutely brilliant piece of work. So just to give you guys the results of our analysis of the Pack SDK and how it works and what the big differences are, and I'm going to try and keep that down to just a few minutes. So essentially, you build a pack. Here's an agent that's being built as a pack, and when you go in, you get all the same things you do with building a pack as you do with building an agent. You have a listing, you give it you give it an icon, you give it a description, and so on. And then when you go in and start messing with the code, it's the same TypeScript code we're used to, but there are some new things in there, like you have this thing called pack add skill and stuff like that. The user interface, I think, is worth just reminding ourselves about, because how the SDK builds something is determined by the user interface. So when you have your Superhuman Go up and running, you have over in the corner of your screen, I think you can see there's the little Barbie doll that pops up. And when you click on that, you're now into the Superhuman Go user interface. And the key thing is that all the agents that I've loaded appear down the side, and I can go and find more agents by clicking here. And so eventually any agents we build will appear either in this list or in some sort of a gallery that allows people to select the agent that they're looking for. So 40 million people who know nothing about me and how brilliant I am will suddenly start to see my stuff coming up here. And, you know, maybe some of them will buy it and I can retire. Although I tried that and it didn't work. But, you know, and you mentioned the Gmail. So when you bring up one of these, like the Gmail one, you get to do a sign in, and then you have to go off and get your account connected and so on. But the key thing is that once this agent is up and running, okay, I'm obviously in a different account to what I was before. Once it's up and running, it has access to everything that is in the window that the user is using. So it can see your screen, it can see what code you've, or what text you've selected and stuff like that. The way it's broken down on the SDK is, I think, into these different areas. What they're calling agents, we've always called them packs. So it looks like a pack, and it just has some extra features on it. So can people read that, or do I need to magnify more?
No, absolutely. Works great.
Okay, you don't need to read the code. Okay, so when you build an agent, you're essentially creating a new pack. So you have your pack header with all the usual stuff, your imports, your export statements, your authentications, your domain. New item is you build skills, which are basically driven by prompts rather than code. You can pick one of the skills as your entry point to give a hint to the system that this is where I want you to start. But basically, it'll pick the skills and the tools based upon the context. The AI is now going to make sometimes fairly non-deterministic decisions, but it's definitely going to do its best to figure out what is the user trying to do, and let me see if I can help. It reminds me of good old Clippy, who used to come up and say, "You seem to be writing a ransom note. Can I help you do that better?" Anyway, and then you have tools, but actually they're not new. They're just formulas, right? All the formulas in your pack are actually become tools. The knowledge base is new, and that is actually sync tables. So if you build sync tables, you can turn them into your knowledge base. So let's look at the new item, which is skills. You have a skill header, which has a name, a display name, which is how it appears in the user interface, and a description. And you're going to see these descriptions becoming very important, because the description, the name and the description, is how the AI figures out what to do. So you're going to be describing this not for some user who's going to just click past it. You're going to have to describe things very well. And it's a bit like what we're experiencing with MCP. The better you describe what the pack is going to do or what the skill is going to do, the better the AI will be at selecting it and making it happen. Inside your skill, you have a prompt which defines the behavior. It is going to determine which tools get used, which screen text is going to be used. Any replacements you're going to make to the user's text on their screen is going to be explained in here. What knowledge is going to be needed from the knowledge base, what knowledge is going to be changed. You describe all of that inside your prompt. So you're going to be really good at prompt engineering from this point onwards, because that's how you're going to drive your skills. The tools, you make a list of tools. So here we are, I'm describing a new skill. I give it a name and a description. It has a prompt. I'll come back to that later. And I have a list of tools. And I'm saying use all the tools that are in this pack, but also use the screen annotation tool, which is the tool that looks at the user screen. And by the way, I'm saying I'm going to do some rewrites. So I'm saying not just reading the screen, but actually being able to do some rewrites. Now, when this is up and running, it has a different context to what we're used to. Normally, a pack has almost no context at all. It runs on a server. It can't see your tables. It can't see your document. It can only see the parameters you pass it. And basically, that's it. Now, it can use an API and so on. However, these new packs that are agents have access to the screen text, the fields that you're in if you're editing an input field, and any text that you've selected. And it will only show you the text. It doesn't see any of the graphic. Well, it doesn't pass over to you anything else other than the plain text from within that context. And you can't see or access any of these from your code in the pack. You will access them all from your prompt. So here this prompt is saying, look for text that looks like this, dollars, or a number followed by CAD. In the user's writing, and use the exchange rate tool to convert this to another currency and create a suggestion using the rewrite tool to replace the placeholder with the value. This is straight out of Eric's example. And I think the documentation is very good because it's led with examples, which makes it a lot easier. So here's a prompt in English. We're now programming in English, and we're telling the agent what to do through a prompt that's inside a skill. And you can have several skills inside the pack so that there's all kinds of situations that the user can get into, and a different skill with a different prompt will be triggered by the AI to deal with each one. But you also have access to the user. So you know the user's name, you'll know their email address, and there's a rough timestamp to the nearest minute. You also have access to the chat history, which is a history of exchanges where you'll see the prompts and the AI responses. But again, only from within your prompt, not within your JavaScript code. When you're writing a tool, as I said, basically you're building a formula. So you have the usual formula header, name, description, whether it's an action or not, and what the return type is. But the name and description needs to be good enough to help an AI figure out, do I need this tool? Am I going to use this tool? Do I use this tool here? What do I pass to this tool? What am I going to get back from the tool? It needs to have a very clear idea of all of that, so it makes a good choice to use the tools. You'll have a list of parameters, again, name and description. The description is important. The AI is going to have to figure out what am I passing over to the tool, and it'll do a better job if your description is spot on. What is the type of the parameter? And then you execute your JavaScript code or your TypeScript code. You have all your usual access to API calls to read data, to write data to other systems, and then you'll return a value. And that value is going to end up in the context of the user's screen, or it'll be used within the prompt to make the prompt do something in the next step. So it's all fairly straightforward code that we've all been used to seeing. There's nothing new, nothing magical. We're just going to have to be a little bit more careful about our descriptions, and we get to do all the usual API stuff that we're used to doing. You know, and you know, it's fairly straightforward if you've been building packs in the past. But what's new, and I think this is a wonderful piece of engineering, how do you get RAG knowledge bases into something as simple as a pack? I really didn't know how they were going to do it, and what they've decided to do is to use sync tables. So your knowledge bases are implemented using the sync table capability. So first of all, you have to create a schema where you define what the columns are, the names of them and what type. And then there are special columns that turn it into a RAG database. It'll be vectorized into a vector database. So here you have your normal schema that you would use when you're setting up a sync table with different columns, the types, the hints. You can do all the usual stuff. Here's a type that is the priority. It's got a hint type, which is select list. It's got options. So you've got all of those capabilities. But what makes it into a knowledge base is the fact that I'm describing these extra special fields, the display property, the ID property, the featured properties, the title property, the link property, and here's how you're going to index it. So these special properties are going to form the chunk that goes to the vectorizing, tokenizing process. And those chunks are going to go into the vector database so that when the AI needs information, it's going to do a semantic search for the data that's been presented here. Not a lexical search. Is going to match the meanings of what's in your knowledge base with whatever it thinks it needs in the context of what it's trying to do within your prompt. And so this is how you create your knowledge base. Without having to go to an external Pinecone vector database or anything like that. So you have your sync tables, and then you're going to have RAG tools, which are essentially formulas that do the RAG, the retrieval and the updating. So for example, to create the knowledge sync table, you're going to have the usual pack add sync table, which you would do for an ordinary sync table, and then the code that builds your sync table. And in this case, it's going out to an external API endpoint to get the data. And here's an interesting one, a RAG tool that is able to update the knowledge. So we're able to add a task to our task database by following the code that you would normally use to add something in there. But now that's part of the knowledge base. And I love this. This means that agents can learn. As a result of what they do, you can prompt them to say, at the end of this, make sure we update the knowledge base with whatever new data we've gathered as a part of this. And so I think our agents can start to learn as they go and know more and more about what the user is doing and what they want. So that in a very short summary is what we have found inside the SDK. And I have to say, I'm very impressed, very excited. The one thing I will say is that this is aimed at personal productivity. The context is a single user on a single window doing single things for themselves. So I'm still waiting to see how we're going to apply this to corporate level stuff or to small to medium enterprises running automated SOPs, which is the kind of agent work I've been doing in the past. But my goodness, this is very exciting and I'm very impressed. So I'll shut up now and let people have their questions.
Wow, Max, I'm super impressed. You've given us you condensed all of our learnings into 10 minutes. Thank you so much. What a privilege to have listened to that.